right, in lesson 6.4, we're going to look at the definition of common denominators. So it says a common denominator is a common multiple of the denominators of two or more fractions. Fractions with common denominators represent wholes cut into the same number of parts. So if I want to find a common denominator for 2 and 3, I want to know, what do 2 and 3 both go into? So 2 and 3 are both factors of 6. So I could make both of these into fractions that have a denominator of 6. In order to get 1/2 into 6, I'm going to multiply the bottom by 3. And whatever I do to the bottom, I have to do to the top. So that would be 3/6. And then if I want to make 1/3 into 6, I have to times the bottom by 2 and then the top by 2. So if I wanted to compare the two, 3/6 would be greater than 2/6, and so making a common denominator makes it really easy to compare those two fractions. Another way to find a common denominator is to use multiples, and we made our list of multiples here. So if I'm listing the multiples of 5 and 2, if I want to find a common denominator between 4/5 and 1/2, if I'm counting by 5s, 15, 20, 25, 30. If I'm counting by 2s, 2, 4, 6, 8, 10, 12, I can see that a common denominator would be 10. So both 5 and 2 are eventually going to go into 10. So in order to get 4/5 to 10ths, I have to multiply 5 by 2, and then 4 times 2 as well. So that would be 8/10. If I want to get 2 to 10ths, I'd multiply by 5 and multiply by 5. So it'd be 5/10. So you can write 4/5 and 1/2 as 8/10 and 5/10. So you can easily see the two denominators are the same. The numerator is greater here, so you can compare the two. Sometimes you don't need to change both denominators in order to make a common denominator. So for example, this one says, find a common denominator for 1/3 and 1/12 by dividing each whole into the same number of parts. Use the models to help. So for this one, I could do 12 and thirds. I have 12ths and thirds, but 3 I know goes into 12, so I could make my thirds into 12ths by doing times 4. And whatever I do to the bottom, I have to do to the top. So 1 times 4 is 4, and 3 times 4 is 12. So now I have 4/12 and 1/12. So my common denominator would be 12. So I didn't have to do anything to this side. I only had to change this one in order to make a common denominator. So now we're going to look at numbers 2, 3, and 4 on page 347. We want to find the common denominator for these different pairs of fractions. So for this one, I know that 2 goes into 4. So I'm going to use 4 as my common denominator. So in order to change 1/2 to 4/4, I'm going to have to do times 2. And whatever I do to the bottom, I have to do to the top. So this would be 4, and this would be 2. So I have 1/4 and 2/4 for my common denominator. On this one, I know that 4 goes into 8. So if I have 3/4 that I want to equal 8ths, I have to times this by 2 and this by 2. So that means 6/8 and 5/8 would have a common denominator. And this one I have 1/3 and 1/4. So 1/3 and 1/4. 3 does not go into 4, 4 does not go into 3. So what I can do is I can count the multiples, or one of the easiest ways to do it is just multiply them by each other. So I'll multiply this by 4 and this by 3, because now no matter what, I'm going to have a common denominator because that's my same multiplication problem. So 3 times 4 is 12, and 4 times 3 is 12. So my common denominator is going to be 12ths. Whatever I do to the bottom, I have to do to the top. So 1 times 4 is 4, and 1 times 3 is 3. All right, for question number 12, we have Jerry has 2 same-sized circles divided into the same number of equal parts. One circle has 3/4 of the parts shaded, and the other has 2/3 of the parts shaded. His sister says the least number of pieces each circle could be divided into is 7. Is his sister correct? Explain. So what his sister is saying is that in order to find a common denominator for each of these circles, the smallest common denominator that we can make is 7. So it looks like what his sister is doing is adding our 2 denominators, because 4 plus 3 is 7. But we know that that's not the way to find a common denominator. In order to find a common denominator, we need to know, what do both of these numbers go into? So we know that 3, if we find our multiples of 3, we have 3, 6, 9, 12, and 4, 8, 12. So they're both going to go into 12s. Or I could use my cross multiplication strategy, multiply this one by 3, this one by 4. Whatever I do to the top, I have to do to the bottom. So this would be times 3, this would be times 4, so they could be divided into 12 pieces. So his sister is not correct, because the least common multiple of 3 and 4 is 12, so the least number of pieces each circle could be divided into is 12. So now on page 348, we have question number 13, which says, Carrie has a red streamer that is 3/4 yard long and a blue streamer that is 5/6 yards long. She says the streamers are the same length. Does this make sense? Explain. So what we want to do is make a common denominator so that we can easily compare the two streamer lengths. So if she has 3/4, we know that 3/4 and 5/6 are our two streamer lengths. And 4 and 6 are both factors of 12. So we can change both of these into 12ths. So in order to change 4 to 12, I'm going to need to multiply by 3. And whatever I do to the bottom, I have to do to the top. And in order to change 6 to 12ths, I'm going to have to multiply by 2. So now my new fractions would be my red streamer is going to be 9/12ths. And my blue streamer is going to be 10/12ths. So you can see that the blue streamer is longer than the red streamer, so they are not the same length. So if we were going to explain this, we could write 3/4 is equal to 9/12ths, and 5/6 is equal to 10/12ths. Since 9/12ths is not equal to 10/12ths, the streamers are not the same length. 14 says, Leah has two same-sized rectangles divided into the same number of equal parts. One rectangle has 1/3 of the parts shaded, and the other has 2/5 of the parts shaded. What is the least number of parts into which both rectangles could be divided? So I want to find the least common denominator for both of these. So I can start by writing the multiples of 3. So 3, 6, 9, 12, 15. I'm going to stop there because I know that 5 is going to go into 15. So that would be the least common multiple that I could make. So 3 times 5 equals 15, and 5 times 3 equals 15. Whatever I do to the bottom, I have to do to the top. So 5/15 and 6/15 is what I could divide both rectangles into. However, the question is just asking us what's the least number of parts that I could divide them into, so that would be 15 parts. That would be our denominator.